All right, so welcome to this video that begins chapter 3. At this stage, I would invite you to pause the video when I step off screen and copy out the notes that are on the board. It should take about 1 page of your notebook, and then press play again and I'll walk you through what we've come up with here. Okay, so in chapter 2, we dealt with a concept called simple interest, and I'll run through what that is again, and then we'll move into chapter 3, which talks about the main form of interest we're going to be examining in this course, which is compound interest. All right, so in simple interest, we call it simple because interest is being charged or accruing, depending on what kind of account we're looking at, interest is being charged or accrued only on the principal and not on any previously charged or accrued interest. And it'll probably make more sense if we look through an example of this. So I have a situation in which I have a simple interest rate of 8% per time period being applied to a principal amount of $2,000. And we had the formula in the last chapter, so I'll just throw it up here on the board. So after one period of time, the AV1, the accumulated value after one period of time, is 2,000 times 1 plus 1 times 0.08, okay? That's the formula, but it's not very helpful. So if I run the 2,000 through, it becomes more helpful. There's my principal, and there is 8% interest applied to my principal. So that's $160 worth of interest added to 2,000 to get 2,160. Now, after 2 periods of time, again, I have the formula 2,000 times quantity 1 plus 2 times 0.08. And if I run the 2,000 through, it becomes more of a useful, intuitive idea. We now see that we've got our principal and then 2 charges of interest on our principal. So 0.08 times 2,000 is $160 of interest. I'm going to get 2 of those $160 payments because we're moving 2 time periods in the future. And that gets us to 2,320. Similarly, after 3 time periods, we'll have our initial amount, $2,000, and then 3 doses of our interest on 2,000. So 3 doses of $160, which gets us to 2,480. So that's simple interest. And the problem will always say simple interest if it intends you to do simple interest, okay? However, for the vast majority of this course, we're going to be focusing far more on compound interest. So in compound interest, the interest rate is applied to both the principal and any interest that we've already earned prior to the time period we're looking at. So in a formula, the accumulated value at time t plus 1 period, so AV sub t plus 1, is equal to the amount we had one time period earlier, AVT, plus the interest rate multiplied by that amount we had 1 period earlier. And so you'll note that the interest rate is applied not just to the principal, the present value, it's applied to everything we had at time t, right? I could do a little bit of algebra. If I factor out the AVT, I have the accumulated value at time t plus 1 is the accumulated value at time t times 1 plus I, okay? So AVT is the accumulated value at time t, and I is the effective interest rate per period. I'll talk more about what effective means, but essentially means that this number is used directly in our computations. Later on, we'll see something called nominal interest, and we'll have to tweak it before we can use it within our computations. Okay, all right, and via the next example, we're going to actually work out this more useful formula for compound interest. The accumulated value at time t is the initial amount we start with times 1 plus I to the tth power, okay? So that's the formula we're going to use an awful lot. Let's see where it comes from. So I'm going to start out with a very similar situation. I've got 8% interest per time period, but this time it's going to be compound interest. And I've got that initial amount of 2,000 again, just as I did before. Okay, with compound interest, after one time period, I'm going to have the accumulated value 1 time period earlier, so the accumulated value at time 0 times 1 plus I. So I'm using this formula right here, where t is equal to 0, okay? So there's my formula. AV0 was $2,000. It was the amount we had at time 0. I was 0.08, and I get 2,160, just as I did with simple interest. However, after 2 time periods, things are going to change a little bit. So again, using this formula down here, this time with t equals 1, I'm going to have AV2 is equal to the amount we had 1 period earlier times 1 plus our interest rate. Now, the amount I had 1 period earlier, AV1, was this amount, 2,000 times 1 plus 0.08. And now I'm going to multiply it by 1 plus I, which is right there. And that would simplify nicely to 1 plus 0.08 squared times the 2,000, which cranks out to 2332. And you'll now see that this is more than in the simple interest example, which should make sense because in the second time period, I get interest on the interest I earned in the first time period, as well as interest on the principal. All right, let's move one step forward. After 3 time periods, AV3 would be the accumulated value after 2 time periods times 1 plus my interest rate. Again, invoking this formula. The accumulated value at time 2 was equal to this amount, 2,000 times 1 plus 0.08 squared. So I'll copy that down into here. And then 1 plus I is 1 plus 0.08. And that simplifies to 2,000 times 1 plus 0.08 cubed, which cranks out to 2519. Okay? So based on that pattern, it's pretty clear that after t time periods, the accumulated value we have is given by the amount we started with times 1 plus I raised to the tth power. And oftentimes we replace PV0 with AV0, or we use them interchangeably at times, the accumulated value at time 0. Okay? So this is the formula we're going to use a lot to push money forward in time. And in the next videos, I'll do some examples of using this formula for a variety of purposes.